Mr. Man, okay? So what did we talk about yesterday?
About finding finding even three-digit numbers in a list.
Okay.
Something.
Yes. Anything to add, Eric?
And we're using permutations.
Yeah.
Use it to and also sort it.
Yeah.
Also use counter.
Okay, so yeah, to do a quick recap. So we are given a list of the integers, a list of single digit, like 1, 2,
Three, four,
we could
five.
have duplicates, yes?
1, 1, 1, 1, 1,
Okay.
2, 2, 3, 4.
So our task is to find all 3-digit number, which is also even, right? And it does not have the leading zeros, okay? Does not have the leading zeros. For example, 1, 2, 2, 3, 0. So what we can have is 1, 2, 2, 2, 2, 0, right? And then
3,
2,
1, 2.
1, 0.
3, 1, 2.
Yeah. So all these 3-digit even numbers do not have leading zeros and has to be sorted in the response in the returned array, okay?
Yes.
And then we talk about two methods. One method is to iterate.
Permutate.
Yeah, permutate, yeah. Basically, this is just to permutate 3-digit out of this n. We permutate this pn3, picking 3 out of n digits. And then once we have this permutation, we need to check if it's an even number. It does not have a leading zero. And then we need to add it to the set, right? Because we don't want the duplicate. Okay, so why do we need the set?
To remember.
So we don't want the duplicate, right? So that's why we use the set. Okay, so why we use the set? Because we don't want to store the duplicates. We only want the unique numbers. And then before we return, we need to sort it, right? The time complexity of sorting is O(n) log n. And then permutation is Pn3. This is the time complexity and the space complexity. Obviously, if all the numbers are unique and even digits, for example, if we have an array of 2, 4, 6, 8, right? And then the full permutation, every permutation of 3 digits is a good answer, and we need to add it to the results, and that takes Pn3 space. But this is not efficient, right? One efficient way, the more efficient way is to iterate.
Counter.
Yeah. So we want to brute force because there are limited number of 3 digits, right? So we brute force. We try each even number within this range. We are saying that we try every 3-digit even number and to see if it can be made from the given digits, right? And how do we determine if it can be made out of this given array of digits? We just use a counter. We count the number of the appearance for each digit and then we compare two counters. If the counter of these digits, the even number, 3-digit even number, is smaller than the given counter, then we say it's possible to make this 3-digit even number using those digits, right? And then this is more efficient because look, this is a constant loop. We just have to iterate how many times? How many even numbers of 3 digits? 999. The last digit is 998 minus 100 divided by 2. Right? Need to plus 1. This is the number of the 3-digit even numbers. This is a constant number, so this is a constant loop. Constant time complexity. If this is not considered, okay? If we are not considering the time complexity of turning the digit into the counter, this bit, we're just talking about this bit has this constant loop. Okay? We talk about this, we talk about that, and then do this full permutation. We use this from iter tools import permutation, right? And then this gives us a nice, easy to use tool to do this permutation of 3 digits. Right? This is the iterator. But basically, we're saying that we want to find a permutation of 3 digits based on these digits given, right? And then we check if it doesn't have a leading zero, if it's an even number, last digit is an even number, then we add it. A, this is 100, B, this is 10, C, this is 1. And then answer is a set. This is to prevent the duplicate numbers, and then at the end we need to sort it, right? Sort it. This is O(n) log n, n is Pn3. Okay, so the time complexity is Pn3, this bit, plus, right? Plus N3 times log Pn3. Oh, this is n log n, right? N, as I said, n equals Pn3. I mentioned the depth search, breadth search, right? We can solve this using depth search, and then in the next lesson, we are solving this using breadth search, okay? What's the difference between depth search and breadth search? Anybody?
Breadth search, you go level by level, but depth search, you go deep as you can.
That's right. Then how do we get the...
And also depth search uses stack, and breadth search uses queue.
Good one. Okay, so what are we trying to do with the depth search here, right? We are trying to implement this commutation, right? We want a 3-digit even number, and this is from the mathematics perspective. We want to find out the 3-digit commutation using the depth search. Suppose we have this digit, right? How do we do this 3-digit permutation? Anybody? What are those 3 possible permutations?
1, 2.
1, 2, 2, and
1, 2, 3.
1, 2, 3.
No.
Yeah, 1, 2, 3. Yeah, that's okay. Forget about the even number. I'm just saying the 3-digit permutation. How to do it? 1, 2, 3.
3.
Okay, is it enough? 1, 2, 0 here, right? So there are a lot, right? We want to find out the 3-digit permutation using the number of digits given, right? So we can do this depth search. So now how do we use the depth search? Let's do this depth search. First of all, we need to counter, right? Counter the digit, right? We need to obviously know this frequency. C equals counter digit. Okay, and then define depth search. Let's say the current number is x, right? And if x is bigger than 99 or bigger or equal than 100, it means that it's a 3-digit number, right? If x and 1 equal 0. If it's an even number, right? Answer equals set. Then we just put it in a set. Answer dot add x, right? And then return. If we have already 3 digits, if it's an even number, we add it to the answer. If not, we return, okay? And then for I in range 10, right? We're going through each digit, 0, 1, 2, 3, 4, 5, up to 9. And then we check. If this Ci, if we have enough digits of I, this is counting how many digits of the digits we are given, right? If it's bigger than 0, then we do this depth search. Okay, so I'm going to put it here, and then if it's bigger than 0, do the depth search. But I have to Ci minus equals 1, and then Ci plus equal 1, right? And then here, this is the same, return sorted answer. One thing is missing here, this one. Depth search. We have this x, this is the current number, right? It could be 1, it could be 2. At the beginning is 0, okay? We don't have enough digits here, so we go to here and we try each digit from 0 to 9. Look, if Ci is bigger than 0, it means that original number we have enough digits from 0 to 9, right? 0 to 9. So 0. So 0. This is turning it into counter is 0 1 time, 1 time, 2 time, 3 1 time, right? Okay. So 0 we have 1 time. That's good. It's bigger than 0. We're using this 0, right? So we take this 0 and we turn it into 0, right? And then we depth search. Current number x. So x times 10 plus I. So what does it mean? It means that look, if its current number is 1, 2, right? And I'm taking another 3, right? 1, 2. So I'm taking the digit 3, I equals 3. So what's x? 1, 2 times 10 plus 3. It becomes 1, 2, 3. Okay? Yeah? And after we do this recursion, we have to give it back, give the digit back, I back, right? Make sense? We talk about the maze problem, remember? We mark it and we need to unmark it. Okay, we borrow the digit I here. Look, we are checking the digit from 0, 1, 2, 3 to up to 9. Then we say, okay, if we have enough digits, C, remember C is the counter of original digit, right? If we have enough digit of I, then we borrow it. Ci minus equal 1. We borrow it and we do the depth search. After we do the depth search, we return it, we give it back, right? So how do we do the depth search? This is the location. Current number is x, right? For example, is x is 12. And we want to borrow the digit 3, right? So what happened to the number? I have 12, and I want to put a 3 on the right. What happened to this x? So now x is 12, right? I have tried 2 digits. Now I need one more digit. The 3, I have enough 3. So I can put a 3 on the right hand side of the 1, 2. So what happened to this x?
It becomes odd.
Yeah, I know, but you know when the x passing here, if you go to here because it's bigger than 99, it's 3 digits, right? So here. So what happened if x equals 12, and then I borrow a number 3, digit 3, put it on the right. So what happened to this x? It's very obvious. 1, 2, and what happened?
It gets a 3. It
Sorry?
becomes 123.
Yeah, so it means that look 12 times 10 here, right? Times 10 means 12 times 10 means that I want to put one digit on the right and then plus 3, okay? Right? Got it? This is the recursion depth search. Make sense?
Yep.
So we need to give it back, right? If we don't give it back, then the digit will be running out and then there's some solution will be missing, okay? Yeah? Which line of code says it's permutation of 3 digits? From where you can see it's a 3-digit permutation? It's a 3-digit permutation.
X bigger than 99.
Yeah. If the x is bigger than 99, it means
The only
it's 3 digit. And it's 3 digit here. There will be a return. Well done. It will be return, right? It doesn't continue to depth search. So the maximum digit is 3 digit. It's not possible to get 4 digit using this, right? Because after 3 digit, we return. We don't do the recursion anymore, right? This is the terminal case, right? And at the beginning, we call depth search 0. At the beginning, we have nothing. And then you try each digit, okay? And which part of code says that it's an even number?
If x and 1 equals
Yeah?
0.
Even? Yeah, this is the even number. And which part of code says that there's no duplication?
Is it a set?
Yes, set. Yes, this is the set. Yeah, okay? Set guarantees no duplication. Stores only unique numbers, right? Unique digit. For example, a equals set, right? A dot add 1. Okay, so a dot add 2. A dot add 3. Okay, a dot add 1. A is 1, right? Contains 1. A dot add 2. So 1, 2. So a dot add 3, 1, 2, 3. Okay, so how about a dot add 3? What happened? A is a set of 1, 2, 3, right? 1, 2, 3. I want to add one more 3 into the set. What happened? Set only stores unique numbers. And if I have 1, 2, 3 already in the set, and I want to add one more 3 to the set, nothing will happen. You can add as many numbers in it, but it only stores 1, 2, 3, and that's it, right? Okay, this is what a set is. Okay? And which part of code guarantees the answer is sorted?
Return sorted
Yeah, that's
answer.
an easy one, right? Okay? So what have you learned today?
About the same as yesterday, finding 3-digit even numbers.
What's new today?
We use depth search.
Yes. What's the time complexity?
M.
Oh, this-
OPM3.
Yeah, this is the permutation. This means picking 3 digits out of n digit with sequence. What's the difference between PN3 and CN3? Okay, one last question. Anybody?
CM3 is like picking 3 apples out of n apples.
And what's the difference between PN3 and CN3? Okay, let's say P32 and C32. What's the difference? There are 3 apples. 1, 2, 3. Okay, 1, 2, 3.
Isn't the C for one? Is one of them kind of like?
Okay, so
Isn't the P like? Doesn't the P like can choose any and C can only choose one?
okay, so one by one. C32. So what does C32 give us? 3 apple picking 2. What are those?
It's 3. So and C is.
What are those?
C is kind of like is the to calculate the C is to calculate one whatever is the factorial, and C is like how much possibilities you can pick from the bottom one, and the top one is how much
Okay.
is there you can pick, and you just need to see how much possibilities to
I'm trying to understand what you said.
Take
Yes.
the top one from the bottom one, and P
You get me confused.
and P is like the is instead of like the picking it is kind of like putting the numbers like 1, 2, 1, 3.
Okay,
It's
so
kind of like so the top one is 2 and the bottom one 3 and obviously the bottom one is how much is the popularity and 2 is how much you have to pick. Basically, they're pretty similar. Instead of C doesn't really care about the numbers and you can use anything like apples or bananas and
Yum.
no P and T.
and P uses numbers. So like 1, 3, 1, 2.
1 million.
And C you can use your imagination and use
Your tongue. So listen, okay. C combination. 3 apple picking 2 apples. How many ways? How many ways? How many ways? 3 apple picking 2 apples. 3 apples picking 2 apples. 3 ways, yeah? 1, 2, 1, 3, 2, 3. Okay?
3, 1.
Look at 1, 2, 1, 3, 2, 3. Okay? And what's P?
2, 1. 3, 1.
2. Look at you. C 1, 2 is the same as 2, 1, right? But P 1, 2 is different than 2, 1. Okay? That's what's the difference. C is this bit. P is both added up together. Got it? So P 3, 2 is 1, 2, 2, 1, 1, 3, 3, 1, 2, 3, 3, 2. C is 1, 2, 1, 3, 2, 3. Right? Combination without considering the order. Or the order doesn't matter. P permutation, full permutation. Yeah? 1, 2, 3, 1, 3, 2. This is permutation, right? 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. Look, full permutation and factorial. Yeah? We talk about that. Okay?
Yup.
Anyway, you talk very good. I was listening to you for like 5 minutes before I figure out you were kind of like joking, right? Good job. Okay, see you later. Bye bye.